All right, we're back to a function that you probably recognize, the radical functions, and including radical functions in this chapter will be rational functions, which will use some of the skills we developed in the chapter that we just finished, working with rational expressions and functions. We want to start off with a radical function. The simplest radical form is the square root. And we want to familiarize ourselves with what that graph looks like, as well as transformations of the graph using the SRT format from before. You're probably well aware of the restrictions on square roots. You can only square root positive numbers. So, for example, the square root of -4 and -1 is undefined, but the square root of 0 is 0. 1, 2, 3, 4, and I get to build a fantastic looking graph. 0 is 0, 1 is 1, 4 is 2, 9 is 3, and 16 is up at 4. And I've got a very nice looking curve, which should go on forever. So we have restrictions on the domain because you can't square root a negative number. So you cannot square root a negative number, which is going to give us restrictions on the domain and also some interesting restrictions or properties of the range. So the domain for this graph, x must be greater than or equal to 0. X must be greater than or equal to 0. X is an element of the reals. And my y value shows that y is greater than or equal to 0, and y is also an element of the reals. So we've got a really nice summary of our SRT work from before, vertical translations, reflections, and stretches, and the notion of inverses there. Something to add to your study sheet for this unit, it's important for the final exam. Vertical translation has to do with the letter K. Take note of whether it's on the left or the right-hand side. Horizontal translations have to do with the letter H. It's always on the right-hand side, and it's always an opposite. Reflections in the x-axis, where you flip y with negative y. Reflections in the x-axis, or in the y-axis, pardon me, x becomes negative x. If you reflect in that special line y equals x, you get the inverse, which has a special notation. You can have vertical stretches, which have precedence for statements on the left and the right. We have to be careful with that. Horizontal stretches, remember, are always on the right-hand side. And we do it in the order of SRT. Can't stress how important that is. So we want to relate information from the base graph to the graph that has translations, transformations made to that. Take a look at this one. So I have a graph that has to move 4 units up. So tick off 1, 2, 3, 4, and 2 units over. And I get that same basic shape heading off. Let's turn the page. I'm going to go all the way to D, where we have some manipulation in a variety of places. One thing I have to do is factor, so I'm going to do that first. Y equals 3 times the square root of 2x minus a half. In order to read my SRT information, it must be a single x. Now let's study what this change. So I have a vertical stretch of 3 and a horizontal stretch of a half. And then I have to move a half in the direction of right. So remember how those vertical stretches work. I'm going to get longer on the y-axis. So my calculator can really help me with this, which is good. My vertical stretch first takes all my y values and moves them up by a factor of 3. So from the original graph, 1 would go to 3, 2 would go to 6, 3 would go to 9. And then I've got to reduce the x coefficients by a factor of a half. So that shifts everything a little bit tighter. And then I've got that horizontal shift of a half moving. So with the help of your calculator and some manipulation, let's sketch that graph. So you can look at your table of values to help identify the domain and the range. X has to be greater or equal to a half, and X is an element of the reals. Y is still greater than or equal to 0, with Y being an element of the reals. Now we can do a lot of work with our calculator to get the SRT stuff going, but it's when we're theoretically talking about domain and range, when they give or when we're asked questions like what's the relationship between A and B. So if A is greater than 0 or B is greater than 0, it's nice to talk about actual numbers. So I'm going to say that A is 5 and B is 5 when I need numbers. So when A is greater than 5, I'm envisioning what A equals 5 looks like and what B equals 5 looks like. How is that going to affect my domain and range? Nothing significant happens there. X can still be or still must be greater than or equal to 0. Y will be greater than or equal to 0, with both of them being an element of the reals. As soon as A becomes less than 0, I'm now talking about A being negative 5 and B being 5. What happens to my domain and range? Now I end up still with X requiring to be greater than or equal to 0, because I still have to square root something that's positive, and X is an element of the reals. But that A value plays havoc with my Y's, and it makes my Y values greater than or less than or equal to 0. Y is an element of the reals. So with A being positive 5 and B being negative 5, now I'm restricted on my x's. My x's must be less than 0 so I can continue to square root positive values. My y will be greater than 0 because I don't have any effect of that A. Now what does the graph look like if both of them are negative? In the case of both A and B being below 0 or negative 5 in this case, I end up with the x's and y's both being less than 0 and the x values and the y values still being an element of the reals. Excuse me, that's it for this lesson. On to the next one.